Hey all, first video here for the Master of None thing. So what is it about? Well, I do a lot of different things. I like to repair cars, I like to do 3D printing, I like to do some 3D modeling, which I'm learning how to do that, and that's going to be an ongoing process, and I'll even post videos about that. I do all sorts of 3D printing, including resin. I've got it under the box to keep the resin from exposing accidentally. I'm also working on getting this 3D printer with my other 3D printer. This is the Anycubic Cobra S1. And then I've also got an old VoxLab Aquila from, I think, 2020 was when I bought it, maybe 2021. That's this guy right here on top of my server stack. And I'll be going through things like maybe improvements I've done on that printer, tips and tricks for auto stuff. I also do woodworking, and so really this is just going to be all about the random projects that I do with those, the lessons that I learn. And I also do things like smart homes and trying to automate homes. So yeah, there's going to be a lot of random videos on here just because I do a whole bunch of stuff. I'm sorry, I'm for some reason looking at the screen and not the actual camera. Yeah. So that's what it's going to be. In short, it comes from the jack of all trades, master of none is oftentimes better than a master of one. Kind of comes from that saying. I kind of feel like I'm a bit of a jack of all trades. I like to learn to do a lot of things. I like to try to do as much by myself as I can. And so that's me, because I feel it helps save money. It builds good skills. So there's a lot of stuff that I can get into, even like computer networking. I like to learn about a lot of stuff and do as much by myself as I possibly can. So that's kind of what this is all about. And this first one is going to be about the stuff that I've done to my VoxLab Aquila to make it work a little bit better. And we'll talk about the importance of calibrations on that. Alright, so we're going to talk about my VoxLab Aquila. Any of you that have had this printer know that it comes with a glass printing bed, which was great right up until it wasn't. When I first got it, it was great. Things seemed to be sticking. I really loved the bottom finish that it provided on the prints. And then I just had the hardest time getting things to stick to it no matter what I did. I even used glue sticks, and you can see it. I had one right there. And it was just a pain in the butt. It just didn't want to work. I lost more prints than I kept. In some ways, I had to babysit a print and then use my little scraper to hold some of the prints down so that they wouldn't peel off the bed before they had enough printed to prevent them from doing that. It was just kind of a nightmare. So I bought a new glass bed, tried it, didn't really solve any problems, and then I ended up buying the Sunlu PEI magnetic bed. And the one that I bought, I'll put the link in the description, but the one that I bought came with two beds. One of them is black color, one of them a gold color, and I think the gold color has a smooth side on it if you wanted to use a smooth bed. Haven't tried that one yet, but so far I've absolutely loved this. Now, the next thing that I have, and you can also see on this, I have converted this to be a direct drive printer. Simply because I wanted to be able to print TPU or other types of filaments, and without direct drive, it was just a pain in the butt. So this is now a direct drive printer. I have custom firmware on here that makes it so that I can have that screen be a different orientation. And then I've also got Octoprint hooked up to this, and there is a file that I use to print an enclosure down here where the Raspberry Pi is inside there, so that it's all incorporated into the printer. And because of that, I've got it hardwired into my network and not on Wi-Fi. So those are some of the things that I've done to this. Aside from that, I haven't done a whole lot. Oh, just today I actually put on some new bed leveling springs, as well as the knobs for bed leveling. And I did that because when I swapped out the build plate, I had probably a good almost 1/8 of an inch difference in height of my glass build plate versus my PEI build plate. And my springs were the original springs that came with this printer, and either they had been compressed enough to where I couldn't get the proper height, or there just wasn't enough spring to give me the proper height. So I bought some new bed leveling springs, just did that today. And then I went through the process of leveling the bed again. Now, I use the Dr. Vax auto leveling G code. And what it does is it semi-automates your leveling. It'll go to this corner, the back corner, that corner, this corner, and then the center. And then it pauses the print long enough for you to level it, and then you hit resume, and it'll go to the next side, and it makes leveling the bed a lot easier. Some tips for that. A lot of people use a piece of paper. I decided to use my calipers to measure this piece of paper, and it was 0.1 millimeters thick. And generally you want a layer height, but for a lot of people you use a 0.2 millimeter layer height. So I folded this in half, used the caliper, and it was 0.2 millimeters. That was almost perfect. I did this, I leveled the bed, and when you level it, you can move your paper just a little bit and you should feel some resistance. So I did that, and that had the bed leveling almost done. But the other tip I would do is I'd say do it twice. Do the bed leveling twice, because as you level it once, it's going to get pretty close. When you go back to do it the second time, you're going to notice you're loose again. Well, that's because as you adjust each corner, it can affect the other corner. So when you do it the second time, you go through, you level the bed again, and it seems to be a lot better. Now, I also have another G-code file that I use that I got off of the Teaching Tech 3D Printing Calibration site, and it has a first layer calibration software that it prints a square here, it prints a square in all four corners, and then one in the center. I wish they would change that so that it prints the center square last. It does it third. It does front, back, the middle, and then the other two. I wish it would do the center square last, so that then you've adjusted each corner, and by the time it gets to the middle, your middle should be centered. I would also suggest printing that twice, and that's meant to be an active leveling thing. It's going to print the first one, and you should be down there adjusting your bed leveling as it's doing that to get it perfect. And on that Teaching Tech website, it actually has steps, what that should look like, what your first layer should look like. And so I went through that twice to get my bed really dialed in. And then even after doing that, when I started to print, even this one was a little off, so I had to actively level this bed just a little bit to get that just right. Hopefully this is going to be good, and I shouldn't have to level my bed again unless I change something. I've been thinking about doing a dual Z-axis on this, although I don't know if I necessarily want to do that, because now that I have the Anycubic Cobra S1, I don't necessarily know if I want to do that. This one might just be my test printer, or if I have something that's a little bit less time intensive, I'll run it on this. And I've even got this up to print 200 millimeters a second, which is actually pretty good for the Voxlab Aquila. Now that I've gone through and done a whole lot of the calibration steps that are on the Teaching Tech website, I'm going to try to do that again, because it talks about calibrating your stepper motors, which I think is really good. I really had a pain in the butt calibrating this stepper motor once I made it direct drive, but that's now good and all dialed in. So calibration, I think, is a primo step to making your printer running the way that you want it. Another thing I forgot to mention, I actually have a Zigbee controllable plug here that the Voxlab Aquila is plugged into. So, and that is hooked up to my smart home, which runs on Home Assistant. So I have that, so I can actually turn this printer on or off remotely without actually having to physically come in here and do it. There was a while that there was an intermittent issue here with the thermistor not reading the temp correctly, so I kept having this thing shut itself off for a thermal runaway. So now that I've got that solved anyway, it's fine, but that really makes it easy for me to be able to turn this on and off, and be able to fully manage this thing remotely, so that I can obviously turn it on and off that way. And since the Octoprint is actually wired through the power supply on this using a buck converter, it all comes on and turns off with the flip of that switch that I can do remotely. So I can completely start a job on this, assuming the bed is clear, without ever physically coming in here and touching anything. So that is also one of the really fun things that I've done with this printer. Okay, so with the Teaching Tech 3D printer calibration, it's all on GitHub, but with this particular thing, what I went through is I went through and did the PID auto tune, I did the extruder calibration, the first layer, I also did a baseline print, and I just used the XYZ calibration cube. I even did the slicer flow calibration, and those were the steps that I did to really bring everything in line. They had talked about extruder E-step calibration. I also did my calibration of both my X and my Y axis, actually all three of them, X, Y, and Z axes, just to make sure that everything was, there it is, X, Y, Z steps calibration. Now, I did all this because I wanted to make sure that I noticed that this printer was printing larger than my Anycubic printer was, and I wanted to make sure they were printing the same size and true to size. If something was supposed to be 20 millimeters, then I wanted to make sure it printed out 20 millimeters. So I would strongly suggest when you get a 3D printer, you go through at least the PID, the extruder calibration, first layer, baseline print, slicer flow calibration, and the XYZ steps calibration. The other ones, retraction tuning and speed and max flow tuning, obviously you can do those if you wish. I just wanted to make sure that everything was accurate on mine, and doing that really helped bring my prints back to good quality when I replaced my E or my extruder stepper motor, because I had to turn it into direct drive. I had just an absolute pain getting everything printing correctly after that, and it was this calibration, stepper motor calibration, that saved my butt with this. Hey, so thanks for watching this video today. I hope it was useful for you and that you learned something new and how to make your printer work a little bit better for you. Feel free to subscribe. I'm going to be making more of these videos coming up on all sorts of different subjects.